All right, so it is 2:12. I guess we should go ahead and get started here. I'm going to introduce the next plenary speakers, which is Dr. Daniel Janies and Dr. Ian Benz. Dr. Janies is the University of North Carolina at Charlotte. He works at the University of North Carolina at Charlotte. He is the Carol Grotnes-Belk Distinguished Professor of Bioinformatics and Genomics. And again, like I said before, you can read their bios in the program, so I'm not going to take up their time by reading all of that. I got to know of Dr. Janies when he was on the Down the Wormhole podcast, which explores the strange and fascinating relationship between science and religion, which the hosts of, one of them is my best friend, Ian Benz here. So I highly recommend it. You should check out Down the Wormhole podcast. Ian is an associate professor of elementary science education at the University of North Carolina at Charlotte. And he is also one of our associate editors for the electronic journal. So I thank you both for being here. I'm going to turn off my camera and kind of fade back. Again, everybody, if you have questions, you can use the Q&A feature. And when they're done doing their talk, we can have time for question and answer. And I'll help Ian kind of watch those questions as they come in. So Daniel, Ian, take it away. Thank you for being here.
Thanks, Mark and Sarah. And
yeah, thank you.
Everybody else who's on.
Okay, so hi everyone. Thanks for joining us this afternoon. So as Mark said, I'm Ian, and I'm here with Dan. Dan, first of all, Dan, do you mind if I call you Dan instead of Dr.
That's
Janies?
fine, yeah.
Is all right. So Dan and I got to know each other several years ago as part of the science festival that North Carolina does. He and I actually sat on a panel discussion about the film Contagion. And then we saw each other again a couple of years later on campus and just kind of slowly started talking. And we actually got to a point where we were submitting grants looking at the role of social media like Twitter on misinformation around vaccines. And we actually did that prior to the pandemic hitting. And then I think once this started, we kind of shifted a little bit, but still with that primary focus of looking at how we can combat misinformation around things like vaccines and now, SARS-CoV-2 and COVID-19. You're looking at that from a lens of nature of science, so in the educational aspect, and also too looking at it when it comes to social media. So anyway, so Dan and I are here to kind of talk a little bit about, as you can see, the science behind SARS-CoV-2 and COVID-19. And hopefully most of you are aware or familiar with kind of where SARS-CoV-2 came from, but maybe Dan, if you wanted to just stress that real quick.
Great.
And give us a reminder of that.
Yeah, so I've been working on coronaviruses for a while. Previous to coming to UNC Charlotte, I worked at Ohio State, and I got to know a senior coronavirologist named Linda Safe, and we were sequencing agriculturally important coronaviruses, coronaviruses in cows and piglets and so forth. And when SARS, I'll call it SARS-1, just so you know what I'm talking about, but it's really the official name is just SARS coronavirus. When it hit in 2002, in juncture of 2002, 2003 in China, the World Health Organization held a meeting, and Linda had come back from that meeting and showed me the slides. And there was this Chinese scientist named Yi Guan who had some coronaviruses. He had interesting data, coronaviruses out of civet cats. You'll see here these raccoon-like animals, small carnivores. And he had some coronavirus out of humans, some of the early cases in China, you'll see from these yellow lines. So the civets are these purple lines and the human cases are the yellow lines. And he had the sequence data, and what he did is he made a cluster of them we call a phylogenetic tree. But I think he was under tremendous pressure to come up with some kind of culprit or some kind of answer. He forced the sequences from the civets to the bottom of the diagram, just graphically, like in his Word or his PowerPoint, and said, "See, SARS comes from civets." And they called all the civets, and it didn't do any good. And what we did was take SARS coronaviruses out of bats and out of these agriculturally important coronaviruses, SARS-like coronaviruses, and we put them in a phylogenetic tree. And we did something called rooting the tree, such that we look for the deepest common ancestor of all coronaviruses. And what we can see here is that the black lineages, these are bat-hosted coronaviruses, actually quite ancestral to the group that became human coronaviruses. And this is the really most important juncture in this tree. This is the past down here, and this is was the present up here in 2003. This black to yellow transmission event shows that bats are the fundamental host of coronaviruses who came into humans first. And then locally in markets in China, in wet markets, there was human to small carnivore transmission, even back to humans. So there's something going on, but it was a small microcosm of the broader fundamental history of coronaviruses. And then paper after paper came out after SARS-1 went away and showed that, yeah, bats are fundamentally important in the history. This is the same kind of tree, a little simpler history of MERS coronavirus, which also was a little confusing. He's a different receptor. This is 2012, 2015 in the Middle East. And he kind of infected their herders and their camels at the same time. So this notion of an intermediate host was actually quite reinforced there, but it was not necessarily at all true for SARS-1. These black dotted lines you'll see are all sideshows. They're not the fundamental lineage of bats to humans that were necessary. And still today, if you look at Wikipedia or the World Health Organization, people still want to say small carnivores caused SARS. They didn't. And what happened was, basically people forgot about coronaviruses. We didn't do much research on them. Papers came out and nobody was hiding anything. The small coronavirus community kept publishing on, hey, we're finding bat-hosted coronaviruses and they're getting better at infecting humans. But there wasn't much support for that research. And then sure enough, in 2019, history repeated itself. It was a very similar event. Early reports in China were an atypical pneumonia. I can remember over winter break, watching the news come in, and I was like, whoa, this sounds bad. And then sure enough, it was sequenced. It was a new coronavirus, rarely SARS-CoV-2, very closely related to SARS-CoV-1. And we all know what happened. We've suffered a year of lockdowns and loss of loved ones and colleagues, and a lot of hospitalizations and lost educational experiences and everything that goes with that. And now what we're talking about is SARS-CoV-2 didn't evolve very much, but now we're seeing variants. And so we're in a bit of an arms race with our vaccination, our social distancing, to try to squash and remove time and space and hosts from these variants. So I'll stop there and we'll pick up from there.
Yeah, so I do want to kind of go a little more into the variants. You mentioned the idea that we're in an arms race right now. So can you kind of maybe elaborate more on that? I know that there are some who may be concerned that if they get this vaccine, what do they do then? Once they're fully vaccinated, is it over for that individual? Are they good to go and everything's back to normal? Or these variants, is there a concern for us that these vaccines will not work?
Yeah, well, there's a couple of research questions there. One is seek the vaccine. The vaccines, all of them are so widely effective. If you looked at influenza over the past 10 years, some of those vaccines were only 20, 30, up to maybe 50% effective, but they provide some protection. And the most important thing about these vaccines for SARS coronavirus is they're all wildly effective, 90% effective, 70% effective. And so even if they're in test tubes, where what they call the neutralizing antibodies are a little less effective against the variants, they can go from 90 to 70% or 50% effective and still provide a lot of protection. At the end of the day, they keep you out of the hospital. They keep almost everybody from severe death or severe outcomes and death. So there's a lot of worry about the variants, but it's by no means anything different than what we experience with influenza variation every year. And they do provide very adequate protection. And those neutralizing antibody tests that show diminished efficacy against viral variants, those are only one part of immunity. You have also your cell-based immunity. And the head of Pfizer said that they're working on it internally, and he hasn't published the data yet, the head of Pfizer vaccines, but he thinks that there's parts of immunity not being measured by those tests, and they are seeing protection, and he's by a cell-based immune response. And so they'll redesign the vaccines as necessary, but he's not concerned, and you should take the available vaccines.
So then, one of the other questions I know I have for you is it maybe a conversation around once we're vaccinated and we've reached herd immunity, if you can actually talk a little bit more about herd immunity.
Yeah,
before we
you
get
can
to the next
imagine
one?
herd immunity being, sort of ping pong balls on a table, right? And infected people bump into each other if there's a lot of naive hosts. The table is full of ping pong balls are a naive host. But as we vaccinate people or distance those ping pong balls off the table, you're much less likely to have a transmission event, to have a person-to-person transmission. So we're basically removing available hosts for the virus and cutting down its chains of transmission. It's unlikely we can eradicate SARS-CoV-2 just because there's so many copies of it out the world, and it's making variants of itself. But what we're going to do is tame it, and we're going to tame it with vaccination in most of the world. There was some talk about it's a mild, some cavaliers talk early on that maybe it was a mild disease and we should just let it work its way through the population. And the Swedes tried that, and the trade-off was much higher death rates in Sweden than neighboring countries. So that it's a brutal strategy, and nobody else tried it. And the Swedes are even apologizing about it right now. So.
Yeah, I remember when this all started, the Swedes, there were people in our country saying, well, Sweden's doing it, why can't we?
Yeah.
Doing it the same way. So okay, so I noticed something that Mark came up that actually reminded me of kind of the next thing I wanted to talk to you a little bit about is that what are your thoughts on the possibility of, you mentioned this earlier too, at the seasonal flu vaccine that we need to get? What do you anticipate, or do you think there's a possibility for a seasonal coronavirus vaccine?
Yeah, I think that's probably on the horizon, that the variants will continue to occur. Not as wild as, coronaviruses don't vary as wildly as influenza does. So maybe it'll be boosters, maybe it'll be, reformulated every 2 years. Certainly there's enough money now in coronavirus vaccines. So whatever needs to be done, I'm sure will be addressed. Yeah.
Okay. And so sticking with the variants theme, someone just asked a great or put in a good comment in the chat about if we let it run its course, if we had gone that route, would that make it where there would be an increase in the variants? I mean, by vaccinating and getting herd immunity, does that decrease the possibility of variants? How does that work?
You're also having, when you have, these millions of cases, you're giving, every time the virus is replicating in somebody, there's chance for random chance for variation. And right. It's thought that some of the variants occurred by infection in immunocompromised people, where the virus in that person could vary and escape. So yes, we will give it not only less chance to infect new hosts by immunity through vaccination, but in doing so reduce its leeway for variation.
Okay. So on the conversation of vaccines, we had heard, had been shared publicly that I guess the quickest a vaccine had been developed was like 4 years or something like that. What happened this time? What made it possible for the process to be so much faster?
Well, vaccines, a few things. Vaccines were not a good business to be in, and so there were only a few companies making them under federal contracts in the U.S. at least, and there were some technologies that were on the shelf, but there wasn't much there wasn't much incentive to innovate. So this adenovirus technology has been around for 50 years, and mRNA has been around. That technology has been around for 20 years. There was not much incentive to bring it to market, and so the Operation Warp Speed brought it to market, among other technologies. And in terms of safety, I don't want to say and by any means they're unsafe. We've had millions of doses given, and there's been very few adverse reactions. The way that they will move through the approval processes was to do certain steps in parallel instead of in sequence. So all the experimentation and clinical trials were done well. It's just certain things that could be done in concert were done in concert, and that allowed it to be a 1-year process.
I think one of the things was the mass production part, right? The amount of money being put in. I remember Dr. Collins talking about that at one presentation he did, is that by the Operation Warp Speed, occurring that they put so much money in that while Pfizer was testing and going through that process, they were also producing the
Yeah,
vaccine and then were prepared to throw it away if they had to.
yeah, whole new types of machines were created to package the small mRNAs into it's really a ball of fat that gets injected into you.
Okay.
That happened in parallel. I would surmise.
Okay. So a good comment just came up to something I definitely wanted to talk about is that you do have this percentage of population who is hesitant to get vaccinated. You do have the ones who are the anti-vaxxers that have been around for a very long time that you and I've talked about in the past, but there is a sizable percentage of the population right now who are concerned about getting any of these vaccines. And Julie Westerlin mentions, 30% of the population may hesitate to get it. Can we reach herd immunity if only 70% are vaccinated?
Yeah, I think we need, the number I read, that the satisfactory amount of herd immunity is 60%. Okay. I'd have to look at what less and more of that means. We'll probably want not achieve more. But it's worse. Look at France. Apparently the anti-vax movement is even stronger in France, and the EU has been overly bureaucratic in the approvals and the rollout, and they didn't pre-purchase a lot of vaccines, and they're having a third wave, and we're knocking down cases. There's mild community transmission here in North Carolina. I know it's not the same everywhere, but if you look at the charts, things are looking good. And in Europe, they're still struggling. So it's a combination of factors, not just vaccine avoidance, but bureaucratic rollout that will help, or non-bureaucratic rollout that will help us.
Yeah. So another thing, I'm curious about. Well, we'll get into misinformation in a few minutes. There was another one that came across I thought was interesting. So I'll read this to you. It's from Cameron. I was talking to a Korean math professor last night. There's very little COVID in Korea right now, and she was nervous about blood clots being caused by the vaccine she could get. In the US, the risk of COVID is so high. This individual says, I'm 100% sure getting a vaccine makes sense because small risk of vaccine is tiny compared to the risk of COVID. So she's asking, is it important for people in countries like South Korea, New Zealand, and Australia, who definitely have a lower amount or less of a breakout than we do, I guess that's the right word, but to get vaccines soon? So do those countries, should they get them anyway?
Yeah, New Zealand's a good example. They're an island. They locked it down pretty good, and they thought they had beat it. It was going to be the first place in the world that they had beaten COVID, and it keeps popping up, right? And they probably have the luxury of being relatively not dense, and they have some certain special conditions in New Zealand. So New Zealanders have to follow the advice of their physicians and their public health advisors. But if they want to travel one day, it might be good to be vaccinated. And I know they like to wander. Korea is dense, though. Seoul is extremely densely populated. And if I were advising Koreans, I'd tell them to get vaccinated. And they actually had an advantage early on because they were one of the places in the world. I was in South Korea at the time. They experienced one of the largest human-to-human outbreaks of MERS, and it was terrifying. So I would expect Koreans to seek vaccination.
Okay. So some other things that are coming across, is herd immunity, do you think herd immunity is achievable without vaccinating children?
That's a good question. I don't think so. I think, even before COVID, let's say we did, have fantastic rollouts of influenza vaccines. It was once asked in a session, where do the new hosts come from? And it's babies, so you don't often inoculate babies early on. And the virus will find a way. Some of the benign coronaviruses that you likely never heard of, they're part of the 30 or so pathogens that cause common cold and are never precisely diagnosed. The doctor just treats your symptoms, right, when you have a cold. Some of these coronaviruses, there's several of them that infect humans. They've sort of evolved to become diseases of children, and they live in children, basically. They make a living in children. Yeah. So that's something to watch for SARS coronavirus too. Those coronaviruses have very benign outcomes, but there's this inflammatory disease in certain children, and that's something we definitely should watch for.
Yeah. And another comment came up, Malcolm, I think I'm understanding your question, but would there be a need to consider different populations and communities when looking at the possibility of herd immunity in the US?
Yeah, I think the more dense places you're in, like I lived in New York City, and I used to get 5 colds a year. I don't know, just because you go to a restaurant, you just have no space there,
Right.
But here in, the central US, or the places where we have more space, I think, we're more naturally socially distant, and herd immunity will be important, but it's not as important as densely populated areas.
Okay. What about, and I remember reading this the other day, that there was a concern, or an expert was discussing, I can't remember who it was, about that even if we achieve herd immunity here in the US, that if the rest of the world, especially the lesser developed nations, are unable to do that because they don't have the resources, that this will just never go away. Like because of world travel, that it will just keep happening.
Yeah, like influenzas, it will become another influenza, which historically we thought always came in from Asia. And so the influenza vaccine procedure was to go to Asia, get the leading strains, bring it back to the US, and formulate the vaccine against those. But then again, we learned in 2009 that a novel influenza could emerge in the US and Mexico. And so anything can happen, but it is a very big concern that coronaviruses will have a reservoir in bats. That's demonstrably true, or minks, or just humans, so
right.
I think the minks cases were very interesting. They're reminiscent of what I illustrated for this SARS-CoV-1. Minks handlers in the fur industry in Denmark and the Netherlands gave coronavirus to the minks, and it started to mutate in the minks and come out and infect other people. So we've got to be watchful of, we're not going to make this go extinct,
Okay.
It and its cousins that are still in the wild are something to be concerned about.
Yeah. So another question that kind of came up, and I've heard Dr. Fauci describe this too in many of his presentations, is that this was almost like a worse nightmare, where it's a virus that you could go from having no symptoms whatsoever to an individual to death, right? That's the range, and that it spreads very simply. And so, can you talk a little bit about that? Why is it, do you think, one, and you discussed this on the podcast episode we did about, why this one spreads so easily than others, and then also two, the level of symptoms. Why do you think it varies so much?
Well, there's like a spread component, and it's good at keeping you walking around, and you're infected for a while before you really know it, and you're going about your business and you're infecting other people, and that combined with exponential growth, that's why it made it so widespread. That's a very successful virus doing its job getting around, and we don't see that from viruses like Ebola, like that kill most of its hosts, right? But in certain people, SARS coronavirus went just past the sort of sniffles, cold, fever, dry cough, to a highly inflammatory disease. I've heard of cases of, especially with people with comorbidities, obesity, vascular problems, and it becomes an inflammatory disease and starts to attack those people's organs, and there's a massive organ failure, and they're dead, and ventilation doesn't even save them because it's not a problem with their lungs. It's basically a body-wide organ failure, and they expire almost immediately.
Okay. So a few other things that just popped up. Do you think, and this is a good point, this individual's asking or making the point, it seems like there's a kind of a fade or less of an emphasis on testing, regular testing. And with these new variants coming around, does that need to be increased? Like go back to the testing, or is testing just not talked about anymore because we have the vaccine?
Well, testing allowed us to get a handle on where the virus was and how widespread this problem was. It's not by no means a cure. I mean, you can with or without testing, you can be safe, right? You could social distance and things like that, but social distancing has a cost, right? An economic cost and an emotional cost and an education cost, right? So I think certainly the attention is turned to vaccines and variants. I think overall, I asked my doctor some time ago, why don't they do more point of care testing? This was before, because I was curious about the technology because I work in genomics. This was before coronavirus, and he said that it wouldn't change how he treated you. So I think testing will become more important at the point of care if the doctors can be convinced that the treatment is different. And I think that will be the crux point. We'll also use it to monitor, the emergence and spread of infectious diseases. But I think that point of care, matter of course testing will be very important going forward, especially as an early warning system.
And I'm going to bring us back just a second to the idea of, the fact that to some it spreads very easily and you can get very ill, to others they don't even know they have it. Why is it then, or do you know why it is within a household, for example, you could have two people who test positive for coronavirus and then they have various symptoms, but then the other two may not get it at all, like not even test positive.
I've heard of that, and I've heard of people's pets getting it, but not their spouse, which is interesting. I don't know. I mean, they just they did good infection control in the house. Would be the only way I can explain it.
Okay. Yeah. So it's not just that that's necessarily your immune response to it itself. It's more how you handle things.
I think that's an open research question. Yeah. Did these previous infections with other benign coronaviruses provide some protection? I suspect not, because the transmission and the R0's been so high that we saw almost no natural immunity. R0 is the number of cases each new case gives, and looks like early on in the epidemic, every new case of coronavirus led to 2 or 3 others, and so that would be lower if there was some natural or learned immunity from previous coronavirus infection.
Okay. So another question I think that popped up was really interesting. Do you know if there are any studies in process that connect people who have received the flu shot with those who had COVID and the severity of their illness or immunity?
No, and they're very different viruses, so I wouldn't expect any cross-reactivity, and I've not heard any serious suggestion of that.
Okay. So, yeah, go ahead.
No, that's fine.
Okay. So, most of us, are educators in some form on here, science educators, math educators. So, as we are slowly getting near the end of our time together, I'm just curious, what are the things you think we in the education community can do to help those of you in the science community when it comes to misinformation?
I think that, I think working together, and I really like the nature of science principles. One of the things that I think has been very difficult and seriously botched in coronavirus responses, that there wasn't clear single point public health messaging, and there was flip-flopping on masks, flip-flopping on social distancing, and it was left up to the governors, and very different rollouts of non-pharmaceutical interventions in different states, and became, as we all know, political football. And really, you got to have single science-based public health messaging, but people have to realize that science is tentative. Research may change that messaging, but it can't be 100 cacophonous messages at once. And that cacophony, that chaos, gives room for misinformation.
Yeah, I think I maybe mentioned to you in an email yesterday or something that I had students tell me earlier this week, young women telling me earlier this week, they were really worried about, they had heard from someone who had heard from someone that if they get any of the vaccines that they could potentially become infertile and not be able to have children. Which when I did a quick search, it's not true, but it's
not been shown to be true.
Right. There's just a lot of pause there for them.
Yeah, and
even should they get it.
and there's been some evidence of state actors trying to disrupt Western society by criticizing Pfizer and Moderna's vaccines and maybe sell their vaccines more readily to the rest of the world. But also, there's even doubt among, like, the EU is a very good example. There's a little data that the AstraZeneca vaccine, which we're not using here, caused blood clots. And one country in the EU, is Norway's, pulled it off. And then I think the regulators throughout the EU got nervous, and they didn't want to be the last person standing giving it out, even though the this blood clots issue was very low percentage, and some people don't even think it's vaccine related. Certainly should be studied, but coronavirus is going to kill a lot more people than these blood clots. And so Europe has even flip-flopped again, started redistributing AstraZeneca, but in the meantime they kind of created their own problem, and it was also wrapped in the politics of Brexit too, because AstraZeneca and Oxford were the developers of the vaccine, and Europe just didn't want to believe it, and was looking for any reason to not believe in anything good coming out of Brexit.
Well, I think that,
so a lot of it's self-inflicted too.
Right.
Yeah.
I think that's interesting. It really touches on a question that just came up. How is it that we can keep both the science community and then the science and math education community ways, are there ways or suggestions you have on how to keep anecdotes from ruling the science?
Yeah, I think they just got to be messaged against right away as fast as possible. And maybe there should be some, you already have health classes, right? In middle school, maybe there should be some updated modules every year about seasonal infections and things like that. That could be one way. And you and I will continue to work on this problem with our proposals. So.
Yeah. And so
I'd like to hear from the community what, not being a secondary school educator, what they think might work, and we'll be happy to work with you on that.
Yeah. One of the things that I'm curious about too, and this is how I approach my elementary science methods courses throughout especially in the fall, and I've done it this semester too, is to really talk to them about how throughout this pandemic, it's been, very tragic, obviously, but also a good, it's allowed the public to see the science process play out, right? Things that usually happen behind the scenes, the messiness of it that the public never sees, they're now seeing. So so I've used that to say, this is how science tends to play out, the tentativeness of it, the importance of evidence when making conclusions. So I'm just curious, what are your thoughts on, do you see the scientific process changing from here on out? Like, are there ways that this for either better or worse?
It has changed. There's this notion of peer review, where it used to take weeks, months really, or a year to publish a paper, because it had to be expertly and blindly validated by several experts and criticized. And then you had to respond to all the criticisms in a second or third version, and that took a long time. And there was an editor in the middle mediating it to get it into a good journal. Now, especially young people are just posting work on the internet that's not been peer reviewed, and they usually put in a disclaimer, and the sites that host this kind of work put in a disclaimer, and they argue rightfully that we're in a public health emergency and they just want to get the results out, and they'll seek peer review later. But I think there's also a danger in that too. I was just today, in preparing for this call, just looking at a study that said that the UK variant, here on the left side of the screen, it was thought to be more transmissible. It's been demonstrated to be more transmissible, but now they have a lot of cases of it in the UK, so they can compare to pre-variant of concern and post-variant of concern rates of death. And the conclusions of the paper is that you have a 1.7 times higher rated death rate with variant of concern. It was just a statistical study. It wasn't a study of the physiology of the virus in your body or anything like that. And so I looked at the data tables in the preprint, and the numbers are almost the same. I mean, the deaths, of 90,000 cases, the deaths are, something like 4,000 on each side of pre variant of concern and post variant of concern. So I emailed the paper to a colleague and he said, yeah, that he doesn't believe the modeling they did. So that's the kind of thing that should be happening behind the scenes. Now it's not even happening, or it's happening in blogs or Twitter. And so it's a bit chaotic. Emergencies breed chaos, I guess,
Yeah.
So I'm old, so young people will keep posting their preprints, but I want to get back to normal where work is reviewed.
Yeah.
Thank you though for asking.
So there's another one in here about the origin of SARS-CoV-2. Do you feel that it mutated in animals to its current genomic sequence, then jumped to humans, or did it evolve to its current form via human-to-human transmission?
Well, both. It did not have an intermediate host between bats and humans that is known. There could be one out there. It's not pangolins. It's not civet cats. It's not minks. It's not anything that we've seen. And that if it was out there, that information may have been destroyed. But certainly the first step was and killing the civets from SARS-1 didn't help. It and its cousins continued to mutate and travel around bats, not even restricted to China. They're traveling around Southeast Asia and Africa. MERS came probably out of African bats. And that group of viruses that we will call SARS-like viruses just got lucky, and certain people, I believe people in Yunnan, China, were doing something like mining bat guano, or just had bats in their town, and there were probably early cases, what we call spillover events, and these people weren't rich enough to seek health care, or just got over the cold, and maybe they died, but the rate of mortality in these villages was high enough that it wasn't seen as anything specific, anything outrageous. And then I think some of these people who carried in their bodies SARS-CoV-2 to Wuhan, which was an urban area, people are tightly packed together, and then we started to notice it. There are papers on early SARS-like cases were data collected in 2017. So this was probably a slow-burning fuse. You could trace it back to SARS-1, but SARS-2 was probably happening in 2017. We didn't notice. And then in 2019, it got into a big city and we started to notice, and genomics got applied to it. We could actually detect the disease. There's no evidence besides the minks and that SARS-CoV-2 is using a reservoir, and minks are a post bat to human or human to human transmission event. Okay, so that's a late event. Hope that answers the question, but that's, to me, that's one of the most fascinating questions about these things is how they emerge and what they do post emergence.
So is it possible then, I mean, with the way these things emerge, I mean, I would think it's probably highly unlikely, if not impossible, to just shut them down from ever happening again, right? I mean, these things will continue to happen. So how do you see a way that with SARS-like viruses continuing to happen, ways that we could handle potential outbreaks in the future?
They seem to emerge in places where people are interacting with animals that they normally wouldn't. Bushmeat, going into forests. Bats are responsible for several kinds of viruses, Ebola, Nipah, Hendra, and so I think, much more research has got to go into bats. They're a big swath of the culprits, and a better economic way to make a living than killing wildlife. It would be a great start.
Yeah. Okay. And let's see if I have anything else. I think that's kind of it on my list of questions I have for you. I know we're running low on time. We have 5 minutes left. Does anyone else have anything else they want to ask? Or if not, Dan, do you have any closing remarks for the people here today?
Just get in touch with us if you have great ideas how we can get better infectious disease type information to the teachers in the classrooms, and get vaccinated. And I wish you well going back to in-person school. I'm certainly looking forward to it.
Yeah, so am I. With my students, I had a talk the other day with all of them. I got my first vaccine. I got the first Pfizer shot almost 2 weeks ago, and had to tell all of them about it and just mentioned I had it. And that's when I learned about their concerns of fertility. Several of them were hesitant with the idea of getting vaccinated. And so I'm just trying to get them to recognize the importance. And actually, one more question did come in, I think is interesting. The long-term immunity from the vaccine. So we don't,
Still
do we
a
know that
research
yet?
question. We don't know. There'll probably be, reformulations and boosters. Seems like you're protected after 2 weeks after the second dose. And I don't want to venture a guess. I mean, hopefully
Right.
for all of our sakes, it lasts a good amount of time.
But that would be, if it does not, that would be the reason why we would have maybe seasonal vaccines. Is that correct?
Yeah. Well, your immunity could wane, and or variants of coronavirus can continue to move around in naive hosts and infect people who even been vaccinated in 2020, 2021.
Yeah. And actually, one last one that popped up, that's something that people have asked me about. The potential for long-term illness. I'm assuming this is from COVID, or is it potentially? I've heard some people say that, well, the speed process again of the development, that even though I know that's not accurate, it's not accurate to say that, oh, it was too fast. But what is it that makes the 3-month trial?
Well, to be honest, I mean, there's a non-zero chance of a bad outcome with vaccines. People have to consult their physician. Vaccines for influenza used to be made on eggs, and if you had egg allergies, you had to avoid them. And there are rare cases of bad immune outcomes. There's this thing called Guillain-Barré syndrome that first started to emerge in '76 through a flu vaccine, and a small number of people do have adverse reactions to vaccines. I don't think every death is attributable to the vaccine. There's a very small fraction of deaths. If you do something to 1 million people, some probably was going to be the day they expired anyhow, just on numbers. But there is a board of the U.S. government to look at vaccine adverse reactions. Just like driving in your car, it's a low probability of death anytime you do so.
And I think, Dan, you can go and stop sharing your screen now too, if you'd like.
Great.
So
Well, guys, this was really, really fascinating. There were some excellent questions brought up, definitely relevant to teacher education and science teaching. So we really appreciate both of you for coming out and doing that. That's fantastic. And you have their email addresses are also in the program. So if you want to get a hold of them and reach out and ask questions, they'll be available for that.
Yeah, please.
Well. All right.
And one last thing, Mark, I just want to make a point. So someone earlier said parents and students need to hear this kind of information together. Absolutely. Yes, I 100% agree.
Absolutely.
Definitely.
Yeah, that's a very good idea.
Well, we've got a 10-minute break showing up. We have one last link. So once we come back from this 10-minute sort of biological break, there's a link in the master sheet that'll take you to the international perspectives on the COVID-19 pandemic. We've got 5 speakers from various countries around the globe. And then that will continue all the way through the closing remarks. So there's just one more link we've got to navigate to, and then we're done for the day. So Daniel, Ian, thank you so much for coming. We really appreciate it.
Thank you. And I'm putting one more note in here. We are actually going to interview Dan again for our podcast. We're going to work that out because we just hit a year since we did it the first time. Yeah, downthewormhole.com. Check us out. So, all right. Thanks, everybody.
Thanks, everybody.
Bye-bye.